All right, and here we are. Okay, so back in the GraphQL model here, to make this quick recap of what I have learned so far with GraphQL, which is a new way of building front-end and back-end applications. It's a new query language. That the beauty of this is we can see how all of the different pieces of data relate each other in our server. And it all starts by describing the data using a schema. And if you want to ask for data, we rely on queries. And this is much like selecting property from an object. And one of the great things of this is since our query really match closely what the returning object we get, we can predict what our query will return, including the property fields, regardless how the data is stored. Right? So this is the entry point of a whole new universe, specifically for building new APIs and how do we interact with them. That it was created by Facebook in 2012 to solve two particular issues: the underfetching and overfetching. So underfetching means that we lose additional extra request round trip query multiple collection of value to compose data on the front end, adding load time, unnecessary page load time. And the overfetching is that from the server it sends data to the client, usually on too much information that on the client we need to filter out the relevant data that we present to the user. So how GraphQL solves this issue that comes from RESTful architecture? By having one single entry point, so there is no more underfetching, overfetching. You also have schema and types, and it speeds up the development. So I also look the graphical this front end, this built-in browser tools to make queries to GraphQL servers, see how that works, what are the things that it's doing behind the scenes, and by default GraphQL query fetch data, and the specification from GraphQL. This document was that Facebook created at 2012, and more than a little bit of the package where we can use with GraphQL, such as Relay from the React framework, okay, and the Apollo, this high-end product to build front-end and back-end GraphQL applications. So then it started to solve, or before dive deep into the GraphQL or the Apollo specifically, I saw how can we create GraphQL from scratch by looking at what are the packages that we need to install in your Node.js application. I use Express to build that in a GraphQL middleware, and see how by creating a type system where you describe all the capability that this GraphQL serves, and this type system is used by GraphQL to determine if a request operation is valid, the shape and the type of the returning object or the returned response, and verify if the input value of a variable is valid at request time. So I saw how can we create, or how can I create, is this uh, schema, okay? And a more realistic scenario, which is designing is an e-commerce application. In there, I face is a challenge that GraphQL at scale apps face, such as how do we break our types into multiple files? How can we organize our server per features or functionality? And how can we organize our server when we need to add some complex logic to fetch our data? So GraphQL tools package is very helpful here because this is something that on this is being used underneath the hood by Apollo, all right, and provide you a set of open source utility. And because we want is to create an e-commerce that is scalable, so we modularize first our schema, rely on package or using functions from the GraphQL tools package, like makes executable function or this makes executable, yeah, this the makes executable function, which is here, okay, the makes executable function. So when we pass is an array of types, and to modularize our application or GraphQL server, well, we use this GraphQL file extension, where by using functions like low file sync, where it will hold the execution until that function is until that function has successfully executed. By looking at all of depending on the parameter you pass, or mean here is that depend of the argument that you pass to indicate where would you like to find in the project structure for GraphQL files. So this is something that is so by looking at all of these files, right? Just to blah, blah, blah. To recap this last section is that by using files by using a function called low-sync file, we can now is tell that function where are the GraphQL files located that we want to import in the next executable function. Okay, this is for schema, and now we're going to do the same, but it's for another main component in any GraphQL server, the resolvers. So resolvers are a function that determine is the value of a property. So this action, the resolver, can be answered, that question of what resolvers are can be answered at how do we query data. So GraphQL always verify if a request operation is valid, and if it is, they execute that, and while executing, it will call a function called resolver to determine is the value of that property. So each property has a resolver. So on the server, once all of that resolver has been called, it wrap it up and send back to the browser. Okay. So how can we modularize our GraphQL server now for resolvers? Pretty straightforward. So you have to define is a file called resolvers. Let me open here Visual Studio Code. Mhm. A resolver, okay. Hmm, interesting. Okay, that's right. Uh, a resolver, a resolver, okay. That is something that is being used by this next executable function from the GraphQL tools, this set of open source utility for make our GraphQL server much more scalable and maintainable. So by looking at the GraphQL tools here, the guild.dev, okay, so they mention is that it's a set of utility for fast and development of GraphQL schemas. But it also provides some other utility as well, right? So back here to the code, we want is to make our resolvers modular in this GraphQL app, and we do that by defining a file called resolvers.js. Okay, so the name of the functionality .resolver.js, and we export that model with an object that is the query for that. And here's where we define all of our queries. So the cool thing of this is that resolvers allow us to make asynchronous code. Okay, so that resolvers allow us is to make asynchronous API code, which is great. And we test this by using is the promise, all right? And also look at the anatomy of the resolvers. Meaning is that what are the arguments that this function receives? The first is the pattern, which is the root value of the GraphQL server at the start. Then you have is the argument used to define parameterized queries. So for example, when we want to filter out data and then send back to the client. The other is context, that is data shared across different resolvers. For example, in authentication, you want is to share the user's login in different resolvers, and the info, which indicate is the current state of the application or the state of the operation. Okay, if you don't need to use that argument, a good practice is to set that as underscore. Okay, cool. Now, because this is much like as the controller from the RESTful architecture, here in the resolvers, we want is to call, see, because we want to keep resolver as flat and simple as possible. We just only make the HTTP call is on the data layer, meaning on the, in this case, the product of model. So because I define here is this hard-coded data for the purpose, and defining all the data access functions, okay, and then export that function. Again, this is something. This is where we're going to perform is our API calls, right? This is also part of the cohesion, higher cohesion, and lower uh, uh, So higher cohesion and lower decoupling. So for example, this is a higher cohesion, higher cohesion, lower decoupling, high coupling and low cohesion. Cohesion refers to the degree at which element of a model class belongs to another, or mean is the responsibility. I think this is something called from exactly high cohesion and low coupling is so important. So high cohesion and low coupling give us better design code that is easier to maintain. That's one of the main reasons why we do this. High cohesion element within one class or model should functionally belong all together to do one particular thing. Loose coupling among different classes and models should be the minimal dependency. So higher cohesion means that particular model has a lower degree of responsibility, whereas the loose coupling or low coupling means that how all of these models depend each other. The degree of dependency among all of these models, the lower the better. So that's the reason why here we use is this data access layer. Okay, so in this case, well, this file is only responsible for handling API operations. Okay, this the resolvers are only responsible for dealing with data from the front end. Okay, so incoming uh, data or dealing with what it does the resolver, which is after all assign the value to a property. That's all what it does here. That's all what it does here. So get me that data and return that. Simple like that, right? As far as the high cohesion and low decoupling. So looking at the product model here, okay, I already defined here is all of this data access function. We export that, so we got it here. This the product resolvers as well, and here is where we define is all of our query, and also if you want to send parameterized query, meaning if it wants to filter out data in our query where we pass data, for example, here I need to use I need to set this Node.js version because newer versions are incompatible with this Express middleware. And for demo purpose, I'm just using this. And run the server. So I run the server, npm star. I navigate here to the graphical, okay? And here is where we define is the what? And here's where I define is this one. I don't think we will get that exactly. It's because I cannot see that well. It's a syntax error. Okay, there you go. Cool. So this is parameterized query. Okay, I know how to do that. Okay, for a range or for to get an individual element. Okay, and when it comes to look at the other operation that we can perform to a GraphQL server. So believe it or not, you in any so believe it or not, GraphQL query is not only for read data. You can also is change the state of that. So the way of doing that in GraphQL, since reading and gathering data in any API is probably the most frequent operation that you're gonna do. That's why GraphQL focus really well on that. When it comes to deal with other crew operations such as create, update, and delete, you rely on a mutation keyword, which under the hood it behaves the same as the query, like this. Okay. Under the hood, it behaves the same as well. Mhm. And this is the resolver layer. And there you go. Mutations in action. Mhm. So, okay, I mentioned that this is the mutation, and the mutation, these operations are the two main type of operation. Uh, the GraphQL serve support, the GraphQL server support. There is a distinction between the two main components of any GraphQL server, the schema and the resolvers, and the operations you can perform. The queries for ask, for gathering or reading data, and mutations for change the state of your data. Okay, so implementing a mutation on the server, I already saw how can we start doing that. Okay, why not? No, come on. Okay. Mm, okay, I'm gonna make a quick pause here, or mm, only show that. That's right. Mm, yeah. On the meantime, what I'm doing here is just opening is this password manager called KeyPass, and be able to load the credential for this website. Okay. Now it's going to reload this. That's right. So it showed me that. Great. We can get in here. Please continue. add one, sign in, Jesus. Okay. Let me change the URL link here. Like, okay. Okay. And navigate to Node. Here. Okay. Cool. Cool. Oh my god. Okay. And so jump to GraphQL at once. Okay. And the implementing a mutation on the server.
Welcome back. How do mutations work on the server side? In this video, we'll implement two mutations. First, the ability to add new products to our products model. And building from there, we'll add the ability for users to add new product reviews.
Okay. So okay, implementing a mutation on the server. So here, yeah. So here we are going to implement.
Sounds fun? Let's do it. We'll add new products to mutations. In this video, two mutations work on the server side. In this video, we'll implement two mutations.
Exactly. So here we're going to implement two mutations and see how it works. The mechanism. Okay.
First, the ability to add new products to our product model.
Okay. The ability to add new product. Okay.
And building from there, we'll add the ability for users to add new product reviews.
Okay. And from there, give users the ability to add new product, new product, the autocorrect, okay, review.
Sounds fun? Let's do it. Where do we start? With GraphQL, it's always by looking at the schema. Here in
So in GraphQL, it's important to recap this. So in GraphQL, we always start with our schema.
our products.graphql file, right? With GraphQL, it's always by looking at the schema. Here in our products.graphql file, right below our queries, we'll add another root level type.
Okay. So back, what?
Here in our products.graphql file, right below our queries.
Exactly. So right below our query, exactly, our queries,
We'll add another root level type.
Right below our query, we add another root level type. Important here, we add another root level type. So when I look at this specification in GraphQL, okay, which is here, okay, root type, okay, root level type, root type for all of your query operations, set the language support translator. Root type for all of your root query operations. Exactly. Root type, root operations type. Exactly. So again, here we're looking is at the specification, okay, and contrast what I have, what I'm learning here, what I'm hearing right now from this video, and see how can I relate that to the GraphQL specification. Okay, it's like okay, okay, cool, cool, okay, okay. So we have root operations type. The query root operation type must be provided and must be an object type. The mutation root operation type is optional. If it's not provided, the service does not support mutation. If it is provided, it must be an object type. Similarly, the subscription root operation type is also optional, and it is not provided. The service does not support subscription. So the query, mutations, and subscriptions root type must be all different type if provided. Uh-huh. Must be all different type if provided. The field in the query root operations type indicate what fields are available at top level of a GraphQL query operation. For example, this example operations, query, my name, type query is only valid when the query root operation type has field name my name. Similarly, the following mutation is only valid if the mutation root operation type has a field name set name. Mm. When using the type system definition language, a document must include at one most schema definition. In this example, a GraphQL schema is defined with both query and mutation root operation type. Query and mutation root operation type. Query and mutation. And here is where you define that. When using the type system definitions language, a document must include at most one schema definition. Uh, so schema is another way to define this schema. A simple GraphQL schema which is well described with the type here. Interesting, interesting. Meaning that if I define here on the types here, the type query, okay, okay, mm-hmm. Yeah, it's quite redundant here. It's quite redundant to use a schema for that. Schema extends schema and the types. Okay. Mm, mm, type person name no speech. Okay. Okay. Okay, but this is no. I don't want to dive deep here. Not at all, not at all. This is a type system, completely, not at all. This is a schema for that. And understanding is the root operation type. Crucial here. Okay, root operation types. And again, so far on this course, what I'm looking is at the surface of how can I create is a GraphQL query. And also by relying on some copywriting, you know, some they hire some copywriters to create that, or perhaps they made their own script to mention, to tell, to talk about that. Okay, okay, okay. Mm-hmm. Okay. It's like okay. It's like okay. So the root operation types here are the query. In the query, the type must be provided and must be an object type. Mutation are optional and subscription as well. So you can define subscription here. Interesting. So when you mean, what do you mean with subscription here? In What do you mean with subscription here? So for example, type system extension, interface, direct introspection, type introspection, validation, execution, response, appendix, notation convention, okay, algorithm, appendix grammar summary, the language, and the type system. Since this is an operation, here the type system, the description, type system extension, and the schema, root operation types. Okay, root operation types. When I look at the type, is wrapping types, input and output types, type extension, scalar, an object, interface, union, enum, input object, list, non-null, directive. Subscription in GraphQL. Subscriptions in GraphQL from Apollo. Looking at the GraphQL subscription in GraphQL and Relay. Event-based subscription. Interesting. Event-based subscription. Why not live query? Notably, this approach requires the client to subscribe to the event that it cares about. Another approach is to have the client subscribe to a query and ask for updates every time the result of the query changes. We didn't take the approach. Let's put back the data we have to refresh the story. Someone like the post, someone likes the post. Each of those effects also becomes tricky when there are thousands of people to subscribe. Scalability. Implementing my query for this set of data proved to be immensely complicated. Immensely complicated. When building event-based subscription, the problem of determining what should trigger an event is easy. Since the event defines that explicitly, it also proves fairly straightforward to implement a top-existing message queue system. For live query, though, this appears much harder. The value of a field is determined by the result of the result function, and figuring out all of these things that could alter the result of that function was difficult. I've pulled on the server to implement this, but that had an efficiency and timeliness issue. Based on this, we decided to invest in the event-based subscription approach. Parallel that of mutation. Just parallel that of mutation, just as the list of mutation that the server support describes all the actions that a client can take. The list of subscription that the server support describes all of the events that it can be subscribed to. Because a client can tell the server what data to reflect after perform a mutation with a GraphQL selection. The client can tell the server what the data it wants to be pushed with the subscription with a GraphQL selection. Mm, Yeah, this is an advanced topic, but a very interesting one as well. In addition to query mutation, GraphQL support a third operation type subscription, a root level type. When do you use subscription? Small incremental change to large object. Low latency real-time updates. For example, a chat application's client wants to receive new messages as soon as they are available. You should use subscription for the following: low latency real-time updates. Subscription cannot be used to listen to local client events, like subscribing to change in the cache. Subscription intends to be used to subscribe to external data change and have those received change be stored in the cache. You can then leverage Apollo client observability model. You can leverage Apollo client observability model to watch for changes in the cache using client.watch query or use query. Okay, but this is that topic. Using is the WebSocket for that. Okay, on the server side and on the client side. Counts coming subscription TCQL. Exactly. You're going to perform this query, which is a subscription with this. Incoming added. So call that with this data you're going to provide and determine its ID and the comment. And listen for the response data. Instead, your server only push data to your phone when a particular event occurs on your backend. Exactly. When a particular event occurs on your backend, it will push data. Whenever your GraphQL server does push data to subscribing client, that data conforms to the structure of the executed subscription. Setting up the transport. Exactly, using WebSocket for that. Split communications by operations recommended. To support this, the Apollo client library provides a split function that lets you use one of the two different links according to the result of a Boolean check. The following example expands on the previous one by initializing both GraphQL WS link and HTTP link. And it uses a split function to combine those two links into a single link. Authentication over websocket optional. This is something interesting, by the way. This is something interesting. This is something interesting. Again, it's using it as the React client for iOS, for Kotlin. Mm, build your supergraph, graphene, REST, federation. Technical reference. Using a standalone. Exactly the REST API, the microservices in the database. So with that, okay, you just want to explore, you just want to understand is this root in GraphQL service, this root level operations, query, mutations, and subscription.
which will hold all GraphQL file. Right below our queries, we'll add another root level type, which will
Okay, another root level type. Okay.
hold all of our mutations. Our query type includes all operations that just read data, while anything like adding a new product or a new product review goes in the mutation type. We'll start with add new product, which
Okay. So we're going to start here at with the product. Okay. Like always, in any GraphQL server, it'll start with here on our type file. Since we want this to define is a uh, two capabilities, add a new product and add a new product review. Okay, this is the two capability that we want to add. Well, we can do that by using is the keyword mutation. Okay, and this when you define is now the capability of this GraphQL server, the mutations capability. Add a new product, add new product. Okay, and here you're going to pass this.
will accept some arguments that capture the data we need to create a new product object. Let's grab those fields. We'll have one argument that takes in the ID, which is of type ID and is
So since we want to create is a new product, we need to some arguments that are required, some like the ID. Okay.
required. We have a description, that's a string, and
So we have the description that this is in a string. Okay, this must be required. The review then might be optional.
also required for every product. Next, we have the reviews, but it doesn't really make sense for a product to be created with some reviews already attached to it. The reviews are
That might be optional. That's another thing. Because it makes no sense to create a product with some nested reviews. It's important here.
added by sense for a product to be created with some reviews already attached to it. The reviews are added by users later on.
So because it makes no sense to create a product with some nested review will be later on added by a user. Excellent.
So luckily,
Again, this is for designing a new comment.
our reviews field is optional, and we can move on to the price, adding that as the final argument. Price is a float that is also required.
As the price. As the price, which is a float that is also required.
Now, as with any query, we can set a return type for this mutation.
Like that. So as with any query, we add the return type.
And that is also required. Now, as with any query, we can set a return type for this mutation.
So as with any query, we can set, not add, set the return type for this mutation. And this is, well, part of the new practice.
And we'll say that when we add a new product, we get back that product that we just created. This is a fairly common pattern.
With any query, we'll set the return type for this mutation. And that is this. No. Oh, shit. Okay. Come on, man. Come on. Come on. So with any query, we set the return type for this mutation. Product. Okay. This is a fairly common practice. This is a fairly common practice
In APIs to make sure that the right data was saved.
So this is a fairly common
For this mutation. And we'll say that when we add a new product, we get back that product that we just created. This is a
exactly. This is a fairly common practice. Setting the return type as product.
fairly common pattern in APIs to make sure that the
This is a fairly common. This is a common, fairly pattern in API. In API. Exactly. So this is a fairly common pattern in API, setting the return type as product.
right data was saved.
To indicate that data was safe.
There's our mutation. So what comes next? We need to add a resolver for our
Next, we need to add a resolver.
new mutation. Because mutations
We need to add a resolver to our mutation. And
Our
because
top-level operations.
exactly. And because mutations are a top level operation,
Just like our queries, we add them not under the query.
Just like our query, we add that
Object, but instead under the mutation object.
we add that under we add that under right below right below under the mutation object, which is this. So under the mutation object, exactly. So once I define is the mutation, that this is one of the root level operations in a GraphQL server, similar like queries or subscriptions. Queries are mandatory, whereas mutation and subscriptions are optional. Here, set the mutation type, set the mutation return type as product, a fairly common practice in APIs to indicate that data was safe. Okay, so we need now to define is a resolver here. Since mutations are a top-level operation, we define that right below the query under the mutation object. Under the mutation object.
Which is also a map or an object.
Exactly. Which is a map or an object
That takes the name of, but instead under the mutation object, which is also a map or an object.
Okay. Right below under the mutation object.
That takes the name of our mutation, so add new product, and sets it to some resolver function. We'll use this anonymous function, and the arguments to our resolver are the exact same as with our queries. The first argument is this parent, which we won't use, so we're going to set that as underscore, following the same convention as before, but we will make heavy use of these args that were passed in, which contain our product data. What is the body of our resolver going to look like? We're going to make some function in our products model that will add a new product. And we're going to put all of the logic to create a new product and save it to our data model in this function to keep our resolvers as thin and small as possible. We want these resolvers to be independent of whichever model we choose to use, whatever database we're using, and any other implementation details. All we're going to do is pass in all of our args into this function. The arguments we need are args.id, args.description, and args.price. This function will return back the product that was added, so we'll return that value back as the result from our resolver. That's the GraphQL part. But how does our model implement this add new product function? Let's take a look in products.model.js, where we'll add a function at the bottom that we'll call add new product.
So with all of that, I'm going to keep things simple, and I'm going to keep things simple and wrap up this video. And with that, wish you the best. So until the next episode. Take care. Bye bye.